So now we're going to look at the first derivative and second derivative of a uh, parametric equations. So these parametric equations are you have an x and a y, and they're both written in terms of t, and we're looking for dy dx. So notice there's no t involved. So it's useful to look at this in a more Leibniz notation. Like if you want to figure out the derivative of just this x dx dt, that would be very easy. Same thing with y. Now if you want to find out dy dx, it's really like a combination of the two. The reason why Leibniz notation works very well on this is because if you combine these as a fraction, so say dy dt up top and dx dt up bottom, it looks like these dt's may cancel and you're left with dy dx, which really isn't happening, but it's a really good way to look at this. It's going to work. It's a nice way to remember this formula. This will work. So the formula, the way to calculate that's not what I want to do. The way to calculate dy dx for a set of parametric equations is just like that. Take the derivative of y with respect to t over the derivative of x with respect to t. So we're going to do that. So dy dx would be the derivative of y with respect to t. That's pretty simple. That's 12 e to the 2t minus 3 e to the negative 3t minus 4 over the derivative of x with respect to t, which is at negative 7 e to the negative 7t. So we're done. The second derivative. Now that's a little bit more confusing. To take the second derivative, basically on these second, third, fourth, fifth derivatives, the denominator, the dx, will not change. You basically just take the derivative of your dy dx and put it over the denominator. So I know right away that I'm going to have this denominator of negative 7 e to the negative 7t. But now I have to take the derivative of this whole thing, dy dt. So what I'm going to do is make it easier on myself. And I'm going to factor out the negative 1/7 and combine the e's. So this would be 12 e to the 9t, because all you're doing is you're really splitting it up, and I'm subtracting exponents. So 2t minus negative 7t is 9t, and so on. So minus 3 e to the 4t, and then minus 4 e to the positive 7t. That's just going to make this derivative easier. And so up top is the second derivative of this, which I'm going to write out right now because it's going to be easy. Negative 1/7 is a constant, and I just worry about taking the derivative of all of these. So 9 times 12 is 108. So I have 108 e to the 9t, and I have minus 12 e to the 4t, and finally minus 28 e to the 7t. So that's kind of a mess. You could clean it up pretty easily. The negative 1/7 over negative 7 is 1 over 49. And I can do the same thing with my combination of these exponents. I have 108 e to the 16t minus 12 e to the 11t, and finally minus 28 e to the 14t. So hopefully I didn't make any dumb mistakes here, but that's how you do it.